Hey guys, so today we're going to continue on with our chemistry unit. This lesson is all about nomenclature, so essentially how we name different compounds. For this, we are going to be going both from the formula to the name of the compound, as well as from the name of the compound to the formula. And we're going to be doing this for a bunch of different types of compounds. So we've already learned how to identify ionic and molecular compounds. Those both have different naming rules. So do acids and bases. So we'll learn how to identify those and what their naming rules are. And so do multivalent metals. So we'll talk about what all those things are, how to identify the different compounds, and then the naming rules that apply to each of them. Okay, so for this lesson on naming compounds, we are going to be talking about how to name ionic compounds, how to name our covalently bonded compounds, which are our molecular compounds. We're also going to be talking briefly about naming acids and bases, as well as multivalent metals. And then we'll learn a couple exceptions to those rules, though we're not going to get into a lot of that. So first thing about naming is before you try and figure out what the name of a compound is, you have to figure out what type of compound you're dealing with, because different types of compounds have different naming rules. So as we've talked about already, if you have two nonmetals bonded to each other, that is a covalent bond. So covalently bonded molecules will have one set of rules. And then if you have a metal and a nonmetal bonded to each other, that is an ionic compound, and they will have a different set of rules. Most of the bases that we're going to be dealing with are ionic compounds. So they will, for the most part, follow ionic compound rules. Our acids are going to follow a completely different set of rules. And when we get to that, I'll talk about how to identify an acid. So we'll start with naming ionic compounds. Ionic compounds are probably the easiest to name. You just write the name of the metal first, then the name of the nonmetal, and then you just switch the ending to IDE. So for example, NaCl here, Na is sodium, Cl is chlorine, and so the name of NaCl would just be sodium chloride. With the next one, it would be potassium chloride. Okay. Now, working backwards with ionic compounds is a bit more tricky. If we're given the name and need to determine the formula, you have to use something called the crisscross rule, which is essentially where you cross over your charges. So when it comes to writing the formulas for ionic compounds, this is where having the charges of your different elements memorized is really important. So all we're going to do is we're going to write the two different elements involved. We're going to write their charges in superscript. We then cross over their charges and then put them in lowest terms. We also don't bother writing in any ones. So let me go over an example of what that would look like. Okay, so for the first example that we're going to go over here, I'll start with aluminum chloride. Oh, my pen doesn't work. Wow, do I have any pens that work? Aluminum chloride. So we'll start by writing the formulas for each. So aluminum is Al, chlorine is Cl. Then we're going to write the charge of each. So aluminum ions always have a charge of +3 because they're in the 13th column. Chlorine ions, being in the 17th column, will always have a charge of -1. And then the crossing over method just means that we take these charges and we cross them over to the other compound, or sorry, the other atom. So we end up with aluminum with a 1 and chlorine with a 3. When we cross them over like this, we don't write the plus or minus signs. And then we just make sure that our numbers here are in lowest terms. So just think of like a fraction needs to be in lowest terms. 1 and 3 are already in lowest terms, and then we just don't bother writing in the 1. So AlCl3 would be our final answer. Let's try magnesium sulfide as well. So the symbol for magnesium is Mg, sulfur is an S. Magnesium has a charge of +2, being in the second column, sulfur -2 because it's in the 16th column. Then we take our charges and cross them over, getting rid of the plus or minus signs. So we end up with Mg2S2. And then we can put this in lowest terms. And just like if a fraction was 2/2, that could also be written as 1/1. The same applies in this case. And as I said before, we don't bother writing in our 1s. So what has essentially happened is that our 2s have canceled out to just leave us with MgS. Now, things get slightly more complicated when we deal with multivalent metals. Multivalent metals are some of the transition metals that have multiple possible charges. And so if you have a multivalent metal, you do need to include in the name what the charge of that metal is. And we do this by using Roman numerals. So right after the name of the metal, you have to put its charge in Roman numerals. And then we cross over our charges like normal if we're going from name to formula. If you're going the other way around, you have to do a reverse crossing over. So I'll kind of go through some examples of this. First of all, when we're talking about our transition metals, just a reminder, transition metals start in the third column here, and they go the whole way across and underneath the staircase. So kind of from the 4th row down, so kind of starting right here, the whole way across, and everything that's down underneath here. Okay, all transition metals, some of those are multivalent. The ones that you need to be most familiar with are Fe, so that's iron, Pb, which is lead, should also be familiar with Cu, which is copper. Those are kind of be the most common ones that we're using of our multivalent metals. So for the example I have at the bottom there, we have lead for sulfide. Again, when we're given the name and going to the formula, I'm just going to write the symbol for lead, which is Pb, the symbol for sulfur, which is S. Then I'm going to write their charges in. So sulfur is not a transition metal. It's in the 16th column. It's always going to have a charge of -2. Lead is a transition metal. So I don't just know its charge. That is what this bracket tells me. This is a 4 in Roman numerals. So that tells me that lead has a charge of +4. It's always a positive number. Okay, so that is what that means. And then just like we do with all of our ionic substances, we cross over our charges, which leaves me with Pb2S4. And then I need to put these subscripts in lowest terms. So just like if I had a fraction of 2/4, I could write it as 1/2. I can also write this as Pb, imaginary 1, S2. And that would be my final answer. It's actually a little bit trickier to write the name of an ionic compound that has a multivalent metal. We start by just naming it like a normal ionic compound where we write the metal's name, then the non-metal's name, change the ending to IDE. The only difference is that we do need to put the charge of the metal behind the metal's name in Roman numerals. So the example that we have here is that CuBr is copper 1 bromide, whereas CuBr2 is copper 2 bromide. So the next example that we have is Fe2O3. So when we do reverse crossing over, I'm just going to write out my Fe and my O, and then I'm going to start by writing out the charge of the atom that I know the charge of. Iron is multivalent, so I don't know its charge, but oxygen always has a charge of -2. And then if I were to cross that over, it would leave 2 iron. And as I can see here, I do have 2 iron, which means that this has just crossed over normally. And so in order to get the 3 oxygen that I have here, that must have come from the charge of my iron. So that tells me that my iron has a charge of +3. I can now write the name of this compound as iron 3 oxide. Let's try it with FeO instead. So this one's a little trickier. Again, I'm going to start by just writing my Fe and my O. And then again, I start with the thing I know the charge of, which is the oxygen. So I know oxygen has a charge of -2. And that charge should cross over and give me 2 iron. And yet, as you can see in the original here, I don't have 2 iron. So something must have crossed out that 2 and left nothing behind. And the only thing that could do that would be another 2 that would have got canceled out at the same time, which means that in this case, the original charge of my iron was +2. So this one is iron 2 oxide, not iron 3 oxide. So that's how we deal with our multivalent metals. Next up, we have our covalently bonded compounds, also called our molecular compounds. Naming these kind of basic covalent compounds is trickier than naming our ionic compounds because we use something called prefixes, and we only use prefixes for covalent compounds. So we start the same way as we would with our ionic compounds. We write the name of the first element, then we write the name of the second element, then we change the ending to IDE, which is so far the exact same way as how we name an ionic compound. The only difference is then we follow that up by adding prefixes in front of the name of each element based on how many of that element we have. So the prefixes, you do have to have them memorized up to 10. So mono is the prefix for 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. The other thing is we don't use the prefix mono for the first element. We would only ever use that for the second element. So let's go over how to deal with some of these examples here at the bottom. Okay, so we have sulfur dichloride. So sulfur is just S. Chloride refers to chlorine, so that's Cl. And then this prefix of di in front of the chloride tells us that there are 2 chlorines. If we were to do carbon tetrafluoride, carbon is a C, fluoride refers to fluorine, so that's an F, and then tetra tells us that there's 4 of the Fs. This actually makes it even easier than with ionic compounds to kind of write the names and stuff, write the formulas, because unlike with ionic compounds, we don't need to do any crossing over. So the charges don't matter. All that matters is these prefixes here. They tell us how many we have of each of the elements. So let's go the other way now, where we start with the name and we're given the formula, or we have to, start with the name, have to write the formula. So we've done that twice. If we had nitrogen trihydride, again, nitrogen is an N, hydride refers to hydrogen, and then tri would mean that there's 3 of them. Let's do some practice going the other direction. So if I gave you the formula P for Br6, then I would start by just naming my elements. So I have phosphorus, and I have my bromine, which turns into bromide, because I always change the ending to IDE. And then 4 goes with the prefix tetra, so it would be tetraphosphorus. And then 6 goes with the prefix hexa, so tetraphosphorus hexabromide would be the way that we name that. Another important thing that you have to memorize is our diatomic molecules. We have briefly talked about these already. So diatomic molecules, also called Hofbrinkel, are elements that never occur by themselves. So they could be bonded to other elements, like nitrogen and hydrogen are both diatomic, but you don't see little 2's behind them because they're bonded to something else. Same with bromine, doesn't have a little 2 behind it because it's bonded to something else. But if I was told I only had nitrogen, not nitrogen trihydride, I can never write just an N by itself. It would have to be N2. That is nitrogen. Same with bromine. If I was told that I had bromine, that can't just be Br, because it's a diatomic molecule, it has to be Br2. So we only care about that when it's by itself, it has to be bonded to another one of itself. That is our diatomic molecule. Also, if you saw N2 as a name, we would never write it as dinitrogen. It is just nitrogen. However, if you had, say, for instance, C2, I would have to call that dicarbon to show that there's 2 of them, because carbon is not diatomic. But as soon as I have O2, I wouldn't call that dioxygen, because oxygen is already a diatomic molecule. I would just call it oxygen. So make sure you have your diatomic molecules memorized and you know what that means for them. Okay, naming acids. Next year, we're going to learn a bunch of different ways of naming acids. This year, we're just going to use the traditional way of naming acids. first of all, you identify an acid because it starts with the letter H. All acids will start with the letter H. You're then going to write the word hydro in order to reflect that H that's there. Then you're going to write the other element's name, change the ending to ic instead of ide, and then write the word acid. So for example, HCl is hydrochloric acid, HF would be hydro for the H, and then fluorine would become fluoric, and then the word acid. HBr would be hydrobromic acid. Okay, there are some exceptions to this, and that is when we get into something called polyatomic ion acids. As you can see with each of these that I've used as an example here, we just have hydrogen bonded to one other element. If you have hydrogen bonded to two other elements like S and O, or in this example down here, N and O, you no longer write hydro, you would write sulfuric acid. So as soon as you have hydrogen bonded to more than one other element, you no longer use the prefix hydro. You just write the name of the second element, change it to ic, and then write the acid. So if you kind of compare H2SO4 and H2S, because this is polyatomic, meaning that there's more than one atom here bonded to the hydrogen, we don't write the hydro. This one is not polyatomic. There's only one other atom bonded to the hydrogen, so this one would be hydrosulfuric acid. And we'll get into these types, the polyatomic ones, more in Chem 20. You just kind of have to be aware of them for now. These types, you do need to know how to name this year. We're not going to worry too much about the theoretical ionic names this year. Again, that's something that's more important in Chem 20, but really it's just you name the two elements. So it would just be hydrogen fluoride for hydrofluoric acid, or hydrogen bromide for the hydrobromic acid. It's just another way of naming them. So it would be hydrogen sulfide. Okay. Yeah. Okay, naming bases. For the most part, the bases that we're going to be dealing with have an OH group, which is called a hydroxide group. That's kind of how we identify bases, is by that hydroxide group. So all we do is we write the name of the first element, which is usually a metal, then you write the name hydroxide. With bases, you do need to cross over your charges though. So if we're dealing with bases, if you had CaOH2, that is just calcium hydroxide. If you had KOH, it would be potassium hydroxide. A common exception of that, and it's the only base that doesn't have an OH that you need to memorize, you do need to know that NH3 is called ammonia. That's the common name for NH3. And like I said, when we're kind of working backwards from name to formula for bases, you do need to do your crossing over. So for example, if you had aluminum hydroxide, aluminum is Al, it's in the 13th column, it has a charge of +3. And then hydroxide, you do just need to memorize the charge of. Hydroxide has a charge of -1. And then we cross those over and end up with AlOH3, because remember, we don't bother writing in our ones, but I will write in that 3. And then to show that this 3 that crosses over goes to the entire OH, I do need to put the OH in brackets. So it would end up looking like that. I could also do barium hydroxide. So barium has a charge of +2, hydroxide always -1. If I cross those over, I end up with BaOH2, and you do need to have the OH in brackets. And then polyatomic ions, those are like the ones that there are multiple things attached to each other. So this SO4 has a charge of -2. It is a sulfate ion. CO3 - 2 is a carbonate ion. PO4 - 3 is a phosphate ion. And so you might see some of those popping up this year, but for the most part, we're just going to skip questions that involve polyatomic ions. You should just know, if I say the word polyatomic ion, what I'm referring to. It's always a nonmetal bonded to some oxygens with a charge, and that charge could be crossed over, like if this were to bond to hydrogen, or if it were to bond to like a sodium. So you might see the charges crossed over. If I were to bond this to like a calcium, it would look like that. So you might see molecules like this. You have to know how to deal with them in terms of like balancing them in chemical reactions, but we're not going to get into naming them this year. That's something we'll deal with in Chem 20. So those are all the rules for naming. You do have to memorize all of those rules. There will definitely be some questions later on in this unit that you won't be able to do if you don't know how to name compounds. So this is something you should really prioritize. But that's it. So just to kind of review the different things you have to know how to name, you have to know how to name your ionic compounds, also your multivalent ionic compounds, your covalent or molecular compounds, your diatomic molecules, your acids, and your bases. So each one of those has different naming rules that you have to memorize and know how to deal with. And for all of them, again, know how to write the name if you're given the formula, and the formula if you're given the name. Okay, that's it for today.